Okay, law of sines is if you have a triangle and this is angle A, the side opposite is lowercase a. If this is angle B, the side opposite is lowercase b. If this is angle C, the side opposite is lowercase c. You can, the sine of the angle measure and the side opposite is proportional to this angle and this side opposite. So what that means is the sine of B is to lowercase b as the sine of C is to lowercase c, as to the side length. And same with A. And it really doesn't matter if you put the side lengths on the top or the sine on the bottom. So what I do is I set up a triangle. In this case, I have x and y. I don't even know what the third side of the triangle is. It doesn't matter. I'm just going to make it z. So I have, I should stay zoomed out a little bit. So I have that the measure of angle x, find the measure of angle x if lowercase x is 10. Lowercase x needs to be across of the angle x. So I'd have to write lowercase x is 10 right here. Lowercase y is a sine length, and this is 12. And the measure of angle y is 18 degrees. So I can use law of sines and write the sine of 18 degrees is to 12 as the sine of x is to 10. So it doesn't matter if you put the sines on top or on the bottom, as long as you keep being consistent. So I need to put both side lengths on the bottom, both angles on the top. And now I'm going to solve this proportion by cross multiplying. So it's 12 sine of x, so I write 12 sine of x equals 10 sine of 18. So to solve for x, I divide both sides by 12. And now I have the angle with sine of 10 sine of 18 over 12. So what I want to do is do sine inverse. Don't do sine inverse at the very end. Don't put this in your calculator and round it, and then divide these and round it. I don't want you to do this until the very end. So at the very end, I put in my calculator inverse sine of 10 sine 18 over 12. And then I end up getting 14.9 degrees. So about 14.9 degrees if I round the nearest tenth. Which makes sense because remember, the smallest side is opposite, the shortest side is opposite the smallest angle. And then this 18 degree angle is side 12. And so this means it needs to be less. If this is opposite the 10, this has to be less than 18 degrees. Okay, next one, find z. And if I have z and y, so again, I don't have the third side, so I'm going to call that x, y, z. Label my angles. This is 79 degrees. Nope, this is angle y, 79 degrees. This is 79 degrees. Angle z, is 79, oops, too. And then I did read that way, and y was 15. And we'd need to find z, question mark. So across from here, sine of 79 is to z, because I don't know what side z is, as sine of y, which is 79 degrees, is to 15. So to solve for z, I'm going to cross multiply. So I multiply these two, and I get z sine of 79 equals 15 sine of 79. Well, if I divide both sides by the sine of 79, this is going to cancel out, this is going to cancel out. So I'm going to get z equals 15. Which makes sense because if it's across from if if this one is across from Z, or across from 79, it's 15, that means that this one has to be 15 as well. Okay, so find the measure of x. We'll do one more of these. So draw x, y, z again. X, y, z. So x is 63. This is a side length. It's not a degree. We're trying to find x. And then y is 72, which is a side length. And the measure of angle of y is 45 degrees. So I'm going to do the sine of 45 degrees is to 72, because it's opposite as, this is opposite of here, the sine of x, which I don't know, is to 63. Now I'm going to cross multiply, and I get 63 sine of 45 degrees equals 72 sine of x. Now I divide both sides by 72. This cancels out. So now I have sine of x equals 63 sine 45 degrees over 72. So at this point, you want to go in your calculator and do sine inverse. So I do sine inverse of 63 times the sine of 45 all over 72. And I get approximately 38.2 degrees. So again, you want to make sure that you're in degree mode. Okay, and the next one is very similar. I'm going to skip down to finding the area. So to find the area of a triangle, you can use a formula. It is 1/2 BC sine of A. So we have different formulas for triangles. We have 1/2 base times height. In an equilateral triangle, you can do 1/2 the apothem times perimeter, if you remember from geometry. But in this case, we have a formula that is B and C make up the angle. So this is a side angle side situation. So in this case, this is B and C, and they're actually interchangeable. And this is your angle A. So I'm just going to plug it into the formula. 1/2 B times C. So B times C times the sine of 65. So you want to make sure you put this in your calculator in degree mode. So this is approximately 69.8 inches squared because it's area. Number 16. This is a side angle side situation because this side and this side make up this angle. So this is B and C, and this is going to be capital A. So B and C are interchangeable. So I write 1/2 BC, which is 32 times 12, sine of 10 degrees. Put that in your calculator, and it's about 33.3 feet squared. And then number 17 is 1/2. The B and the C are 2 and 3, and it's sine of 35 degrees. So I put that in my calculator, and it's about 1.7 centimeters squared.